Hi all, just a quick video on ionic compounds and how to write their formulas. So we know how to write the formula for ions that are straight off the periodic table. So for example, we might have nitrogen, the ion of nitrogen is nitride, and we can tell by its group number in the periodic table that it actually requires 3 more electrons, so it's going to be an N3 minus. Similarly, oxygen or oxide, when it forms an ion, it becomes oxide, nitrogen becomes nitride. We can tell that. We can tell aluminium, it's aluminium 3+ because it's in group 3. Just remember when you do this that the metals will stay the same name. So as an ion, then the name is the same as an ion, but as a non-metal, and if we're just talking about the elements straight off, it becomes the element with an "ide" on the end, to oxide, nitride, sulfide, etc. Then we have some what we call polyatomic ions. So polyatomic ions have oxygen in them often. They don't have to, but polyatomic means they've got more than one atom. So there's common ones. There's NH4+, and that's ammonium. There is acetate, which is CH3, COO-, so that's acetate. There's phosphate, PO4 3-, so that's phosphate. They're not meant to be arrows. So that's phosphate. There's SO4 2-, which is sulfate, etc, etc, etc. We're not going to go through them all here, but you'll have an activity where we go through them all. So when naming them, what do we do? What we're doing when we're naming is having to try and work out how many of one ion we need to be able to balance the other ion out, because we need to get a neutral overall charge, and overall charge is 0. So if we have something like sodium chloride, for example, sodium chloride, that's made up of sodium and it's made up of chlorine. Sodium ion, which is Na+, chlorine ion, which is 1-, and that's pretty obvious that you need 1 positive and 1 negative in order to get 0, so it forms NaCl. But then sometimes it gets a little bit harder. If we have something like Mg2+, so magnesium, and we have nitrogen, so magnesium nitride, we therefore have Mg2+ and N3-. So how do we work out then what the overall charge is going to be? Well, we cross them. We put 3 there and 2 there. So that 3 is coming from here, going to there. That 2 is coming from there, going to there. That tells us we've got Mg3 and 2. Now that's just a bit of a trick. So Mg3 and 2. That's just a bit of a trick, but if you think about it, it works. If you've got Mg, that's 2 positives. If you times that by 3, you're going to get 6 positives. So I'm just going to write this underneath. And if you've got N2, well, one nitride ion is 3-. If you've got 2, that's going to become 6-. So 6+ plus 6- is going to give you 0. What about with the harder ones, where we've got something like magnesium phosphate? With something like magnesium phosphate, we've got Mg2+, and then we have PO4 3-. Now this PO4 3- is one whole entity. That's not saying that the oxygen is 3-, that's saying that the whole molecule of PO4 3- is actually 3- overall, and it would look like something like this. So it would look something like that. So you've got 4 oxygens around there and 3 minuses. So overall, that whole thing bonded together gives you the ion PO4 3-. So it's just really important to remember that that charge is for that whole molecule. It's not just for one element or something on there. So then we do the same thing. We go 2+, 3-, cross them over. So the 2 is going to go over there, the 3 is going to go over there, which tells me I've got Mg3, but then I have 2 lots of PO4. PO4 is one thing, so I've got 2 lots of that. So that means it's got to go in brackets. So whenever you've got a polyatomic ion and you need more than one of it, the whole thing needs to go into brackets, not just one bit of it. Hope that helps.